Okay guys, we're back at it again. We're doing asymptotes. We did this last semester, so nothing really too new. We have a few different form changes because we have a little more knowledge. Like we can do limits now from the left side and the right side of the asymptote. So we're going to add the calculus twist on it, but it's very similar to last semester. So let's get started. If we take a look, example 1, given f of x is equal to 1 divided by x plus 2, x minus 3, determine the behavior near any vertical asymptotes. So to start the solution, to do this, we must find one-sided limits near any vertical asymptotes. We've got vertical asymptotes at x equals negative 2 and x equals 3. So we pick that up because this right here, if that were to equal 0, we'd have a vertical asymptote because you can't divide by 0. So if this equals 0, then x plus 2 equals 0. Take that to the other side and you get x equals negative 2. And same with this one. If x was 3, we'd be dividing by 0. And we're not allowed to do that. We pick up a discontinuity or, in this case, a vertical asymptote. So let's take a look at this. Let's do the one-sided limit. Just get my pen here. Therefore, we get the lim as x approaches negative 2 from the negative of f of x equals the lim as x approaches negative 2 from the negative. We're actually going to sub in the equation now. X plus 2 and x minus 3. I'm going to skip ahead a little. So you're probably pausing this. You're going to write that little bit. Now unpause it and you can listen to me explain it. So what happens is we are going to have x approach, so this x right here, it is approaching negative 2 from the left-hand side. So that's going to be like, it's going to be negative 2.1, then maybe negative 2.01, negative 2.001. And overall, this whole section here will become a very, very, very small number, okay, on the negative side, multiplied with negative 5 here. So I'm going to have a very, very, very small negative number multiplied with another negative number. So overall, this whole denominator is going to be a very, very small positive number. 1 divided by a very, 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 very small positive number is going to be huge. So it's going to end up approaching positive infinity. Now let's go do the other side. Okay, so I skipped ahead a little, so you can pause it, write this down, and then unpause it again. So we're doing the other side. So what happens is we're doing f of x, and we're finding the limit as x approaches negative 2 from the positive side. So that would be like negative 1.9. Negative 1.99, so we're just a little bit on the right side of negative 2. So we have that all done, and we've put in what our f of x is right here, and then we're just looking for the general behavior. So if we look, we get the lim as x approaches negative 2 from the positive side, 1 over, and what's going to happen is, overall, this whole piece right here is going to be a very, very small positive number. So for example, if I subbed in negative 1.9999999, I would get a very small positive number. So let's write that in. What's going to happen to this overall? So if we look at it, this is a very small positive number multiplied with negative 5. So overall, as this gets very, 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 very small positive, going to multiply with a negative, so overall this is going to be a very, very small negative number. 1 divided by a very small negative number overall, it's going to approach negative infinity. And that gives us our general behavior on both sides of the asymptote for x equals negative 2. Now, we're not going to go through and do x equals negative 3, x equals 3 because it's very similar. So if you want to, go through the process, but it's going to be the exact same thing. So just a few extra words there. This shows us the how it approaches the vertical asymptote, and just put a special note there that it is the same process for the vertical asymptote at x equals 3. We're not going through it, but if this were a test, you'd have to do that as well. Okay, now we're going to deal with horizontal asymptotes, and we had a few rules for this last year. We have actually talked about it at the beginning of this course as well when we were dealing with limits in the first unit, I think. We can do it with calculus, a little more formal, instead of having to memorize the rules. So it says, determine any horizontal asymptotes for f of x. State whether the graph approaches the asymptote from above or below. So let's take a look at it. So we just write out f of x, and we're wanting to look for the general behavior as x goes to, you can either do positive infinity or negative infinity. We're going to do positive infinity. And last year we had a rule that if the degree of the numerator was the same as the degree of the denominator, we just took the coefficient of the highest degree term in the numerator over the coefficient of the highest degree term, which would be the same in the denominator. And in this case, we remember that this would have been a horizontal asymptote of 7 over 2. Now, unfortunately, we've learned a lot more. I guess it's not unfortunately, but we now have the ability to write this a little more formal instead of just relying on a rule. So what's going to happen is we're going to find the limit of f of x as it approaches positive infinity. So let's write that down. So we've got that down. We learned how to do this limit. We would divide the top and the bottom by, and I'll just write it down and then explain it. So we divide the top and the bottom by 1 over x divided by 1 over x. And we learned that at the beginning of this course. And the reason we do that is we chose x to the power of 1 to match up with the highest exponent that we see on x anywhere in the question. So if I had, say this was 2x squared, then it would have been 1 over x squared and 1 over x squared. You pick the highest degree on x in any given term. So when I do that, it simplifies down to this, and we get this. So what happened was I multiplied this into here, and into here, and into here, and into here, and it simplified down to this. Now if I let x go to infinity, this part here will go to 0, this part here will go to 0, and overall I will get 7 over 2. So let's do that. Equals. So I'm going to get a horizontal asymptote at y equals 7 over 2. So therefore the horizontal asymptote is at y equals 7 over 2. Excellent. The next part says to determine, we need to figure out the how it approaches the asymptote and whether it's from above or below. So to determine whether the graph approaches from above or below, consider very large positive and negative values of x. If I sub in a really large value of x and it turns out to come out over 7 over 2, then it's going to approach from above, and then vice versa for below. So let's try that. So let's get this part done, i.e. if x is a large positive number, so large like 1,000, so f of 1,000, just look back up at the top of the question and sub it in, you'll end up getting 7,004 over 1999. And that is bigger than 7 over 2. Therefore, for x very big, so x as x goes to positive infinity, it's going to approach from above. So we write that down. And then we have to do it for very large negative values. So let's write that out. Very same setup. So again, I skipped ahead a little, so you can pause it and write this down and then unpause it to hear the explanation. So if x is a very large negative number, so we try f of negative 1,000, we get this number right here, and you can go and punch that on your calculator and compare it to this on your calculator, 3.5. And since it's smaller, it approaches from below. So you just have to write that out. Therefore, sorry, let me get my pen. Therefore, approaches from below. And we're done that question. Next. Okay, this is our last question, so we're going pretty quickly. That's great. So hopefully the flipped classroom you're liking so far. Determine the oblique asymptote and how the graph approaches it given, forgotten in there, so you can add it in, given f of x. Now you have to remember what an oblique asymptote is. It's not horizontal, it's not vertical, so it's on a slant. And to recognize a vertical asymptote, we have the numerator being a degree 1 more than the denominator. So if you see here the degree, it has an exponent of 2 right here. And this has an exponent of 1, so the degree is 1. If the numerator is 1 more degree than the denominator, then last semester we learned we had to do long division to find the oblique asymptote. So I'm going to skip ahead because we've done this before, so I'm going to write it all out and it's just going to pop up on your screen. If you need a refresher, you can pause it once it shows up and copy it down, and then I'll do a little more explaining. Okay, so this probably just popped up on your screen. You can pause it, write it all down, and then unpause it for the explanation. Just like we were doing before for long division, I'm dividing the denominator by the numerator. So this, and we're going to divide it into this. So exact same as yesterday, I'm looking for a number that multiplies with x to give me 2x squared. That's 2x, and I go through and I do this whole thing. Hopefully we're good with that. And then last year we learned we could write it in this form. That's what f of x equals, okay? So we get the 2x plus 9, which showed up from here, plus whatever you get here for your remainder divided by this, okay? So then that makes our oblique asymptote equal to just y equals this portion, okay? Or this portion here, because as x gets huge, right here, this whole thing will go to 0. Okay, so therefore the oblique asymptote is at y equals 2x plus 9, right there. And or we're going to do it in function notation because it'll make the next part a little bit easier to do the comparison to find out how it behaves at the asymptote. So I just made g of x, couldn't use f of x, that function notation was already used here, is 2x plus 9. So scrolling on down. We got the oblique asymptote. Now it says consider very large positive and negative values to check behavior. So I'm going to write some stuff down, and then you're going to pause it, write it down, and then we'll continue. Okay, so running through this, and once I explain it, you might choose to write it down then instead of doing that first. I sub in x equal to 1,000, and I'm subbing it into the version that we see right here. Sorry for the screen movement. Still getting used to this. I'm subbing it into this version right here because it makes it easier for comparison. And I end up getting 2009 plus 6 over 1999. And when I sub that into g of x, I can see really easily when I sub 1,000 in that f of x is going to be bigger. So when I sub it into g of x, sorry for the scroll again, right here, I can see that's going to be 2009 when I sub in x equal to 1,000. So f of x is bigger. So if it's bigger, then it means when x gets really big, it approaches from above. And let's do a large negative number. So we're going to do x equal to negative 1,000. And if we look at f of negative 1,000, sub it in, we get this plus this small negative. Remember, notice the negative right there. So f of x is going to be smaller than g of x. Now remember, f of x is our function. It's going to be smaller than g of x when x is a negative 1,000 for both, and g of x was the equation for our asymptote. So if f of x is smaller than g of x when x is 1,000, then it must approach from below. And that's it. So much shorter than yesterday's lesson. I think we're under 15 minutes. It probably took you a few minutes longer because you probably paused it at points to copy stuff down. Hopefully you're liking this. Let me know, because if you're not, then we can switch it up. But we'll give it another day or two just to see how you like it. Now again, you see the homework right here, and the beauty part is you're done for the night. Don't go and do that homework because that's what we're going to do tomorrow in class. So have a good night.